Let's look at the quotient rule for trigonometric functions. The keynote is that the quotient rule says if we want to differentiate a function in the form u over v, so a quotient, then that is equal to vu dash minus uv dash over v squared, where u dash is the derivative of u and v dash is the derivative of v. So the examples say differentiate using the quotient rule, y equals tan x, y equals cot x, y equals sec x, and y equals cosec x. For the first example, y equals tan x, we're going to start by writing this as a quotient. So we can rewrite tan x as y equals sine x over cos x. Using the quotient rule, we're going to label sine x and cos x in the following way. So let u equal to sine x, and so therefore u dash is going to equal to the derivative of sine x, which is cos x, and then let v equal to cos x, and so v dash is going to be the derivative of cos x, which is minus sine x. So if we work out the derivative, we get that dy over dx equals to, and now we're going to use the quotient rule. So we have vu dash, in this case cos x times cos x, which is cos squared x, minus uv dash, which in this case is sine x times minus sine x, which is minus sine squared x, all over v squared. In this case, v is cos x, so squaring that gives us cos squared x. And now if we simplify this, we end up with dy over dx, which equals to, and so cos squared x stays the same. We have minus sine squared x, which becomes plus sine squared x, all over cos squared x. Using the trigonometric identity that cos squared x plus sine squared x equals to 1, we can now rewrite this as dy over dx, which equals to 1 over cos squared x. And now this can be written as dy over dx, which equals to 1 over cos x times 1 over cos x. Now 1 over cos x is the same as sec x, and so we can write this as dy over dx equals to sec x multiplied by sec x. And so simplifying this, we end up with dy over dx, which equals to sec squared x. The derivative of tan x is equal to sec squared x, and we've shown this using the quotient rule. For the second example, we have y equals cot x, and so we're going to start by writing this as a quotient again. So we can write this as y equals cos x over sine x, using a trigonometric identity for cot x. And so this is now a quotient in the form u over v, and so if we label this, we have u equals cos x, and so u dash is going to equal to minus sine x. We have v equals to sine x, and so v dash is going to equal to cos x. We differentiate this, we end up with dy over dx, which equals to, and now using the quotient rule, we have the following. So we have vu dash, in this case sine x times minus sine x, which is minus sine squared x, minus, and then we have uv dash, which in this case is cos x times cos x, which gives us cos squared x, and then we have all over v squared. In this case, v is sine x, so v squared is sine squared x. And so in the numerator, we can now factorize minus 1 out to give us minus 1 times sine squared x plus cos squared x, and then in the denominator, we still have sine squared x. And now using the trigonometric identity that sine squared x plus cos squared x equals to 1, we can now rewrite this as dy over dx, which equals to, so we would have minus 1 times 1, which is minus 1 over sine squared x. And now we can split this in the following way. So dy over dx equals to minus 1 over sine x multiplied by 1 over sine x. Now 1 over sine x can be written as cosec x, so we end up with dy over dx equaling to minus cosec x multiplied by cosec x, and so this simplifies to dy over dx equals to minus cosec squared x. And so differentiating cot x, we end up with minus cosec squared x using the quotient rule. Next example says y equals sec x. So again, we're going to rewrite this as a quotient using a trigonometric identity. So we end up with y equals to 1 over cos x. And so we'll start by labeling u and v again. So we have u equaling to 1, and so u dash equals to 0, v equaling to cos x, and so v dash equals to minus sine x. We have that dy over dx equals to, now using the quotient rule, we have vu dash, which in this case is cos x times 0, which is 0, minus uv dash, which in this case is minus sine x, over v squared, which in this case is cos x squared, and so that becomes cos squared x. And so if we simplify this, we end up with dy over dx, which equals to, so 0 minus sine x is just sine x, and then we have over cos squared x. We can split this up into the following now. So dy over dx equals to sine x over cos x multiplied by 1 over cos x. Using trigonometric identities, we have that dy over dx equals to, so sine x over cos x is the same as tan x, and then 1 over cos x is the same as sec x. If we have y equals sec x and we differentiate it, then we end up with tan x times sec x, and we've shown this using the quotient rule. The final example, we have y equals cosec x. So again, rewriting this as a quotient, we have y equals 1 over sine x using a trigonometric identity. So now this is of the form u over v, so we can label it as u equaling to 1, so u dash equals to 0, v equaling to sine x, so v dash equals to cos x. So in this case, we're going to get dy over dx equals to, so vu dash is going to be sine x times 0, which is 0, minus uv dash, which in this case is 1 times cos x, which is cos x, over v squared. In this case, v is sine x, so v squared is sine squared x. If we simplify this, we end up with dy over dx, which equals to minus cos x over sine squared x. And now we can split this up into the following. So dy over dx equals to minus cos x over sine x multiplied by 1 over sine x. So using trigonometric identities, we end up with dy over dx, which equals to, so cos x over sine x is cot x, and so we have minus cot x here, and then we have 1 over sine x, which is equal to cosec x. Therefore, if we differentiate cosec x, we end up with minus cot x times cosec x, and we've shown that using the quotient rule.